Welcome to number 2 in the lecture which I've also had the privilege of co-organising with the Master of University College here, David Held, of course, who is sitting modestly at the back. Number 2 in our series of lectures on the future of the university. Our speaker this evening is in distinguished company. He's following on from our first lecture, which was given by David Horrocks, who is, of course, Vice-Chancellor of the Open University. And he's going to be followed on February the 8th by David Willits, Lord Willits, of course, of the Resolution Foundation, who has had a powerful impact, of course, on the way universities are now. So, thanks, David, for providing these splendid premises for us. And now let me turn to welcome this evening's guest, Professor Peter Coveney. Completed his DPhil at Oxford in 1985. He studied and worked since, and I'm not going to spare you the list, I'm afraid, at Oxford, Brussels, Bangor, Cambridge and Queen Mary College of the University of London. He's currently at UCL, where he holds one chair in physical chemistry, and also serves as honorary professor in computer science. He is also professor adjunct at Yale University School of Medicine. And at UCL, he is furthermore director of the Center for Computational Science. As you'll have guessed from that, Peter Coveney is active in a very broad area of interdisciplinary research, including condensed matter physics, chemistry, material science, as well as life and medical sciences, in all of which high-performance computing plays a major role. I think we can satisfactorily say that Peter Coveney is extremely distinguished. Let me just give you a small taste. Peter has led many large-scale projects, including the EPSRC Reality Grid e-science pilot project and its extension as a platform grant. He is also PI on a large number of current grants from the EPSRC and other agencies, including the role of coordinator of the European Union FP7 Virtual Physiological Human Network of Excellence. He's been the recipient of numerous United States National Science Foundation and Department of Energy, as well as European Union Supercomputing Awards, which provide access to numerous petascale computers. He served on numerous committees of many conferences, including the 2002 Nobel Symposium on Self-Organisation, amongst others, and he was chair of the UK eScience All Hands Meeting 2008. Peter has published more than 400 scientific papers and co-authored 2 best-selling books, The Arrow of Time and Frontiers of Complexity, both with Roger Highfield. And I want to dwell on that just for a moment by saying, if I can add a personal comment, the former book, The Arrow of Time, really does demonstrate the range of Peter Coveney's influence beyond the narrow domain of his science work. It makes him, in my eyes, especially distinguished, because this work, in its German translation, I may add, formed part of my own humble introduction as a specialist in German intellectual and cultural history to system theory and emergent causality, and I devote a grateful footnote to it in a chapter of my own modest monograph on evolutionism in German literature. So thank you, Peter, very much for that, and can I have your autograph, please, on my copy of the book later. Finally, to cut an epic narrative of distinction very short indeed, Peter Coveney is lead author of the first textbook on computational Biomedicine, Oxford University 2014. There are copies available in the foyer, I suspect, and a founding member of the UK government's E-Infrastructure Leadership Council, and a Medical Academy nominated expert to the Prime Minister's Council for Science and Technology on data, algorithms and modelling, which led to the creation of the London-based Alan Turing Institute. Now, however, Peter is turning his attention away from more scientific distinction, yet more of them, and towards how in these difficult Brexiting days we can continue financially to make science research of distinction still possible the day after tomorrow. And that's quite enough from me for now. Ladies and gentlemen, I give you Peter Coveney on the future of scientific research in the UK universities.
Right. Thank you very much indeed for that introduction and the invitation to speak here. I realise that I would like to be able to propagate the slides with a remote control, but if I don't have it, I shall just use the keys here. What I want to do in terms of setting the scene is say things before we turn to the slides, which I want to work through in a fairly systematic way. I'm aware that there are people in this audience from the very beginning of their education, for example, at Durham first year, and I'm delighted to see them here as undergraduates participating in this event. That means I can't assume too much in terms of all the jargon. So I want to be clear that everything I'm talking about here is the result of just open investigations and inquiries, a bit of research that's been done, not only by me but others, and I'll acknowledge them at the end. It's a story that relates to where we find ourselves, as Nick has said, at this moment in time. You might want, in the light of that introduction, to expect I'm going to speak a lot about the science, but unfortunately today isn't the time when we're going to talk about science per se. We're contending with the situation that scientific research finds itself in, and the nature of the funding that dictates where it's going to go. As academics, and the first slide here does speak to that from Michael Pogliani, a view of what we're doing in science, which is not unlike the purpose of the Institute of Advanced Study in Durham itself, to be able to bring people together who, by being together, start talking about things and having ideas that you wouldn't have expected before. That's how you'd like to think science works. And in the notion of academic freedom, that's what we think we're trying to do when we aspire to become scientists. The world has changed a bit. Things don't work quite so well now. We're under a lot of pressure to perform according to various criteria. And one of the things that matters more than anything is money. So money will infuse this talk to quite a considerable degree. Where do you get the money from? Landing of financial income to institutions seems to mean a great deal in the modern era. So much so that people tend to put that in front of scientific discoveries and research. The currency of scientific activity ultimately should be papers and publications. Those are the things you get judged on, but even those become subordinated to the notion of being able to measure things, data, electronic data analysis, big data techniques, metrics, and so on. So we're going to see quite a bit of how the UK monitors the performance of science and academics, and the performance matters because the better you perform according to these metrics, the more money your institution gets, and the money is the thing we're supposed to dance to. So you'll hear a fair amount about that, and the slides are going to take us through all of the issues that I want to discuss today, and this is really a listing of what the topics are. we're going to look at the state of research in the UK. We're going to address the problems that exist in the system and where the money is coming from, and indeed, once it comes into the university system, where it goes. In the scientific aspect of this, one expects to draw funds to do research, but in the modern era, one has to pull in a lot more funding, and a large percentage, often at least of the order of half the money you get in, is then taken by your institution. And one of the questions is, what's happening to that? And there are other things that stand and bear discussion here, which are mentioned towards the end. The question of industrial collaboration. If you were to believe many of the political figures and others who stand and tell us the universities play a major role in what's called innovation, the influencing the economy. It could be a local, regional, national or international one. How do we stand up? How do we stack up in those terms? I want to talk about those. And lastly, in here, I think Nick alluded to that, the issue of Brexit and how that's affecting the way science can be conducted in the future. So this is just a quote from a famous kind of scientist and philosopher of science, Michael Polanyi, and it tells you the way scientists maybe used to think, as I was alluding to a long time ago, that you bring people together. They use their own personal judgment, and by cooperating as members of some group, self-organizing, you can produce things that are unpremeditated and could be radical and exciting. And the attempt to organize such a group can just lead to paralysis. That's an ideal of what one would like to think science is about, which is seldom implemented in the modern era. What people want to do is measure things. How well are we doing in some sense that's tangible? And I suppose ultimately the US has always been the place where you measure things, and the virtue of measurements are their objective. We all agree on them, because it's like counting numbers. It's not an opinion of quality. But so what's been happening for the last several years is we do international benchmarking to find out how good the UK is. And this is what I want to tell you about the official position on. This particular graphic is discussing the state of UK research actually as it is 2017. This is a curious report. It's a BIS report. The source is down there, and it's called International Comparative Performance of the UK Research Base 2016. They were running these things every 2 years. There was one in 2011 and then 2013. There wasn't one in 2015. And then the one for 2016 appeared in 2017. And I have been led to understand that was because they weren't that happy with what the report says. But the headline figures here tell us that the UK punches above its weight as a nation. And they would give you certain statistics to show this. And you can read them there. The right-hand side, so one of the things we think we're good at is publishing papers. And you publish papers, you can measure how many papers are published, and then the quality is somehow correlated by the number of times people cite your papers. So you'll see statistics that tell you the share of world articles here. We don't show the US and China because they're much higher up here. But by this ranking, the UK is somehow at the top of the following pack. And we have this, what does it say, substantial share of the publications, the world articles, and we say the UK has 9.9% of the global population, but we do 2.7% of the R&D expenditure, and we have 4.1% of the researchers. And then there's a metric there which is saying the UK ranks first among comparative countries by field-weighted citation impact. impact. And did you ever hear what the field-weighted citation impact is? It's not the same thing as the citation number itself. It's the number of citations received by a publication by the average number of citations. Sorry, it's the number of citations received by a publication divided by the average number of citations received in the same field of the same type and published in the same year. So it's a manipulated statistic that ends up showing that we're doing well. What I've never seen is a correction for the fact that we use the international language, which is English. Everyone must publish in English. And I would like to see what happened if we corrected that index for the fact that everything we publish is in English. After all, I was doing a review of a famous centre in Germany called the Jülich Research Centre at the end of October, and we had an international presentation, and people there were castigated for presenting work that was only in German. So you see the point that I'm making. We have an advantage in our language which is seldom recognised. Okay, but how well are we really doing? So these are the headline figures for 2018 from these rankings that we perpetually are given to listen to. And actually it's bad news for the QS World Rankings for 2018. 57 of the 76 UK institutions received lower ratings than the last year. And the problem on the left-hand side, where you can see the UK really down at the bottom, is a fundamental lack of investment. So 1.7% of GDP is spent on research in the UK, compared with our competitors, which are typically substantially more. And in fact, that's one of the real reasons why we are having the problems that we do have. Then there's this weird plot on the right, because everyone loves data and analytics in the modern era. You can see this sort of multi-dimensional projection of how we're doing in terms of patents, patent citations, and the UK is the blue thing, the colour is the same on both sides, and you can actually sort of blow that up and see how well we're doing. And in the area of patents and the like, we're actually performing pretty poorly. Not that good. And then we've got this problem that's related to the money, and everyone is seeing these headlines that come up day after day after day. There'll be more to come in a moment. But around the money, there's the question of tuition fees. Are we going to sustain them at the level they're at now? Universities falling down league tables. Vice-Chancellor salary row, deterring university applications. And all of this matters because in the modern era, as I said, money counts above everything else. We need to understand where that money is coming from and what we're doing with it. This slide allows you to take a look at that. There's a few graphics here. The top left this is all open source data you can access and plot. Look at what the series of income fragmentations is between 2008 to 2014. The blocks tell you in different colours how much money is coming from different sources, and clearly the one that's growing like crazy is the student tuition fees. If you look at the one that sort of matters most to this talk in terms of research, this research grant income is that orange thing, and it's barely changing at all. So the income from research and contracts is sort of static, while the tuition fees is growing very rapidly. Funding bodies, for those who understand this, like HEFGE putting money into universities, that's actually been falling off. And down here on the right, you can see the number of institutions. Let's say there are around 130 universities in the UK. 50 of them depend between 65 and 75% of their income is direct from fees. So that's obviously the most dominant message here. If you mess with the fees, you massively mess with their finances. So it really matters. There's a thing up there which is going to come back again later, which is the industry funding. It's actually buried in the research grants. And despite all the things that people say, the amount of industry interactions with universities in the UK is abysmal. And we'll look at that a little later, and we'll wonder why that is. And we'll explain it. But that one I wanted to look at, that's like the magnifying glass on the research income. What's happening here that I want to talk about for the next several slides is that income. Where does it go? So although I said it's static, actually the amount that's coming in to do research, the researcher, the scientist has roughly halved, because in has come the overheads, which are a very substantial fraction of that. And that means less work, scientific work is being done, more money is going to the institution. Why is that? And where is that going? And what are the reasons? Let's look at those questions. So the next few slides here are talking about that income, how it's managed into the universities and where it ends up. So this slide tells you about research grants. Typically, they would come from UK funding. All of this money is kind of in the public domain in the sense that it's ultimately taxpayers' money. And as you can see on the right, there's FOI, that's freedom of information. So everything I'm talking about is in the public domain, or we gleaned it by making requests. We made around 40 freedom of information requests to elicit information that I'm telling you about tonight. You see, on the left-hand side, this is for one of the main funding agencies in the UK called the Engineering and Physical Sciences Research Council. Over the period of the last 10 to 15 years, what's been going on? There's a blue curve which actually tells you the number of funded projects, which has roughly speaking halved, and then there's the number of proposals received as published on their sites, which has dramatically dropped, massively dropped, and that's because of a number of things. One of them is that they filter the number of people that they publish applying, because they only, if there are multi-stage processes, they only report the last stage, and there are quite a lot of those which filter out lots of people. And then there's demand management. And demand management is a punitive measure which says if you make too many applications which aren't successful, you can't make any more. And I could tell you exactly what the details are if you want to know. That's what happens with EPSRC. It's a personal punitive measure. But there are other research councils that do things differently, and NERC does collective punishment, which means if your institution submits more than a certain number of proposals that aren't successful, the whole institution is stopped from making more than a certain number, and therefore collectively they have to decide which projects will go forward. So that's throttling the demand, because in the end they want to be able to tell you that a sort of static ratio of numbers of proposals to successful ones is being maintained, so that you feel good about the number that are going through. So this sort of thing has been going on since the last 10 years or more, and it's really related to what we call full economic cost. And I have to tell you about full economic cost, so listen carefully because it's vital. In 1997, Deering headed up a report that highlighted certain lack of sustainability in funding into universities. He's actually known for the students as the father of university fees more than his implementation or recommendations to implement full economic cost. But the idea was that UK universities were struggling with out-of-date equipment and estates, and we needed to have a better investment in all of this. There were ways of trying to apply for funding to support infrastructure, but wouldn't it be a better thing if we could guarantee all the institutions continued to have state-of-the-art equipment, and that the research that could be conducted would be that appropriate to a world leader in scientific research. So these are details which I'm fearing, especially after a nice bibulous dinner, eyes will easily glaze over if I go into the details here, and I'll show you graphics that demonstrate what this means. But it essentially says that when you put in a grant proposal, you're now asking for lots of things that are supporting the research but are not directly involving what the scientists will do. And that means the value of each grant has started to grow substantially, essentially of the order of twice as much as it was before, but for each grant at that scale, only half of the money is going towards the direct costs of the research. There's things that come in, like the salary of the actual investigator gets charged. Things like the so-called estate costs, which is for the space and other things that you're using, get directly included in the grant that you're applying for. And then this thing called FEC, full economic cost, is what is meant to be then put into your research grant. And the purpose of doing this originally was so that the institution, the university, would be enabled to properly understand the cost of scientific research, how much it costs to do it. When it was first introduced to bring things up to date, it was also recognized that the university didn't really understand what the cost of research was, and this was the opportunity for us to get a grip on it. So 10, 15 years later, these costs have never significantly changed other than to grow. But there's supposed to be a mechanism in here, as stated on this slide, which should tell you exactly how the money is being spent. And that thing happens to be called a transparent approach to costing, or TRAC. And there's an approach to this which means that, for example, the research councils, the ones like EPSRC, BBSRC, MRC, STFC, the research councils put in and agree to pay 80% of the costs of the full economic costs, and they want to monitor where that money is being spent. But you'll see there's a mismatch here between the way it goes in and how it's subsequently audited. But the problems start to accumulate here because this full economic cost model is only really signed up to by the research councils because they work with the government very closely and subscribe to it. There are lots of other funding agencies out there that don't, as it were, know anything about full economic cost. But the universities want them to know about it in the sense that if you're an investigator putting in a grant to any of these other funding agencies, they want you to extract the maximal economic cost from the grant as they define it. Well, one of the problems I've already indicated is the full economic cost model is not funding at full economic cost in this definition. It's 80% of it, whatever you define the full economic cost to be. So even from the outset, the funding agencies which sign up to this are not paying all of it. And that immediately means if you think your research should be paid at 100% of FEC and you're only getting it 80%, you're making a loss. And that's the central reason why, if you work in universities and in circles with management and finance officers, they'll tell you research in universities is loss-making, period. It always is. And a lot of what I say from now on pertains to that observation. You have to believe it's loss-making. And so the question becomes, how do I make up that loss? There's a deficit here. This reminds me of Joseph Stiglitz and the concept of deficit fetishism, which has dominated UK politics for at least 10 years, and it applies as surely in the UK academic sector as it does in the political sphere. So remember, there is supposedly a deficit here. The question is, how much does research actually cost? We've been told there's a number called 100% FEC, and we aspire to make it. These research councils pay 80%. It includes these additional things. It's loss-making by definition almost for essentially all grants. But is it a meaningful calculation of the cost of doing research, and how is it calculated? And that's one of the things our work or research associated with this talk has set out to answer. But if you look down at the bottom, when you make a grant application in a UK university to a research council, the composition in terms of finances looks like that sort of, it's not a unit, it's not a square, it's sort of a rectangle, but there's 4 parts to it. And this bit down at the bottom right is what pays for people, scientists, who are going to go on and do science for you, with you, and become scientists in the future generation. The rest of it is things that are subsidiary to the scientist's perspective, but are part of the grant application. That thing down there matters most to a scientist, but it is elastic. It's not always a quarter of the grant. Actually, I'm very well aware of and participate in grants where the sum of money there is vanishingly small. And the reason for that is they become large projects with several or many academic collaborators, and therefore their time is registered in the PI time, and the grant just consumes all the money paying for them, and there's no money left to do any science with it. So if I hit this, that's what can happen, and the size of that residue is variable. Okay, so it happened that FEC, the full economic cost model, started to come in around 2005, 2006. There was an interesting full economic cost review conducted by Universities UK and the research councils, RC UK combined, in 2009. And I must say, when you get into this subject, it makes quite riveting reading what was written there. But the consequences of this were very small indeed. I noted very few of the recommendations seem to have been adopted. One key recommendation was that institutions should tighten their audit mechanisms to ensure extra money is used for intended purposes, and they're also keen on the notion of sustainability and a relatively short-term model that assures the institution that it's getting money to keep itself going. These kind of discussions are meta because actually what I'm interested in the context of this talk, rather than the global university perspective, is how is this influencing or supporting scientific research? And the reason why I point that out is that there's a bifurcation going on here, because if you're a manager in a university, this is a marvelous system because it pulls huge quantities of money into the institution. And the university might find that its coffers are growing, and I'll show you that's precisely what is happening. But if you're a scientist, I just showed you graphs that pointed to the fact that the number of grants has diminished and the amount of money that's available to research has been going down. So there's 2 different perspectives on whether this is a good thing or not. Let's look at what's happened. Only in the last month here have we started to see, being able to analyse some of the consequences of this. Freedom of information requests that we've conducted reveal that the institutions themselves have no idea where the money is going. They're getting it, but they can't tell us that they're using that money to support or sustain scientific research. It's going somewhere in their organisation. Where is it going? Okay. So there was a report, this is about a month old, from HEPI, which is an Oxford-based independent higher education policy institute. And this slide shows you its findings. And its findings, as headline on the top left, say on an annual basis there's currently a deficit of £3.3 billion pounds per year, which represents, in this diagram, around 27% of what should be the research income. So we're getting 78% of it, we're not getting the other 28%. This is related to the concept of full economic cost. There's a gap. We need it. Otherwise, the institutions are losing money. So then the question is, where is this coming from? And we can see here that you can't immediately connect the numbers on the left to the numbers on the right, so I'll guide you through them. Where do we make good this deficit? And the answer from this report is cross-subsidies from teaching to research. That means the student fees are being used to bankroll scientific research in UK universities. Actually, the report itself says it's all good because essentially it's the international student fees that are making this difference. It's not quite true, even if you play the game and accept the notion of full economic cost at face value, which I'm going to challenge, of course, as well. But it says down here that each international student contributes on average £8,000 during their period to British research. Then you see up here how they define the plugging of the gap, and the teaching surplus at 13% actually translates to £1.6 billion per annum. And then there's other income from the university, which is £0.6 billion. And then there's this mysterious gap that we don't know, but it's presumably generating deficits. But this other income, I should say the teaching surplus, has to make, by anyone's direct piece of straightforward arithmetic, if you accepted this 1.3 billion getting into it from the international fees, it's 0.3 billion going from domestic fees into this. So domestic student fees are paying for the scientific research deficit. We can discuss what that means, but that's not sort of a revelation in the sense that some universities openly say it's a good thing for students to pay fees that contribute to research because that helps them learn better. People can argue about whether that's true or not. But then there's this disparity between the cost of doing a degree if you're a humanities student versus if you're a science student. And overall, if you went into the details, and I'm not going to here, you could make a compelling argument that says that largely humanities students are supporting mainly scientific research. But all of this is predicated on the notion of full economic cost, which is like an assumption here, which we need to question. So before going further, let me entertain you for a few minutes by telling you what happens if you conduct freedom of information investigations. This is a pie chart. Well, first of all, we posed 4 questions to a set of scientific research councils in the UK, which are listed at the top. They were fairly straightforward questions. Some of them were about, do you filter your reports on the success rates, etc. And we had one of the research councils that immediately told us, yes, we do all this. But the others wriggled and squiggled and rolled, but eventually most of them sort of agreed to a reduced question that they were doing something like this. Then we had to ask questions to the HEIs, the universities, and there I'm coming on to more of this in a minute. So as it says here, we asked 12 different questions to these HEIs. Some were to do with, what do you do with your student fees? Are you spending that on research? And on the other hand, your FEC income, what are you doing with that? Are you using that to support scientific investigations? You can see the sort of answers we got here. Very disparate. 1 or 2 gave instant answers. You'll see something about those. More or less complete. And a large number of them refused. There were things like, we don't hold the data, so we can't tell you anything about it. And then there were others that said it will take too long to get the answers. And if you know about freedom of information like I do now, they have to answer within 20 working days, and they're allowed to spend 18 hours getting you the answers. Anything longer than that, and they can tell you they won't do it. Anything, but they'll charge you, and the charges they might levy to you could be typically £45 an hour, and they say it would take 400 hours to do this. These type of answers are what you get. So you get this disparity, and there's this sort of embarrassingly high percentage which haven't replied at all, although legally they should have done. So actually, Imperial College was the only one which furnished complete answers, essentially provided data they had, even if it wasn't everything we asked for. And only in one of the questions when we asked did they say it would be too difficult to provide answers. In the majority of the other cases, the response was a flat-out claim that the questions we asked would take too long to answer. And they didn't attempt to provide any data. So we reduced the number of questions so that they would fit into the 18 hours. And then we got, a few more questions answered. And it was painful. So none of them, including Imperial, were able to tell us how the FEC funds they received were spent, not one of them. And none of them could provide an answer as to how student fees were spent to support research. Let me show you the type of answers we got. They're in a box, it's just illustrative. Let's see, Durham is there as well. So, you know, no one's blushes are spared here. Just look at them. They tell you the university doesn't hold data that shows the percentage of fee income used to directly support research activities, as we don't routinely hypothecate income streams to specific activities. Cambridge income credited to the chest is pooled and used to fund general university expenditure, including research. A fixed percentage doesn't exist. Leeds is saying, I'm afraid we're not able to provide the breakdown of this percentage of tuition fee income that is used to directly support research. Income streams are just not accounted for in a way that would allow us to track the tuition fee income through in this way. Durham, we don't hold information regarding the percentage of that income used directly, etc., etc. So there's a strange thing here. If you're in the academic community, and you know that well, and I'm coming on to that in a minute, there are things like the research assessment exercise and research excellence framework, where everyone's actions, almost every motion that you carry out, is monitored and collected by IT systems, and no expense is spared to find out what you're doing. And in this context, we can't know anything. Okay, but this is publicly accessible information. This tells you on an available site what's going on with the money. The overall budget surplus of the sector. Surplus defined as total income in minus the total expenditure. This plot shows it for the whole of the sector. And it shows you that this is growing at a tremendous rate. Now, if we were running a deficit, why are we gathering so much of a surplus here? I'm looking to someone to explain this to me.
I will later, Bill.
What's that?
I will later.
Can you please tell us? There are moments here where the graph and the axis is accelerating. This is largely when FEC kicked in, and this phase here is also related to student fees coming along. If you think research is a bad thing to do because it generates deficits, then you say, I don't want to stay in research, and there are universities and vice chancellors who would argue this. It's not worth it because it loses money. I'm not going to name them, but there are ones. So it means it's better to just teach students and do research. So let's probe the data and say, what happens if I choose teaching-only institutions and see how they're doing? Wouldn't you expect them to be doing much better? Or research ones, the research-led ones should be making losses. That's the differentiation. If you're in a research-led institution, you're making lots of money. If you're in a teaching-led one, you're barely making ends meet, as they say. So why is that? It seems that if you do research, you benefit. Then we come to all of this stuff, which is part of the attack on universities, and we're all familiar with it. I had a few of them before. Where is the money going? Who's using it? It becomes clear that it's easy to target people who are attracting large sums of money. And then, as I said, if there's a bifurcation in the system, people who are in the line, as it were, academic activities, the basic stuff, the unique stuff that universities do, the uniquest bit is the research, are sort of feeling the pinch, and they're perpetually asked to keep putting your proposals in. And by the way, make them to the research councils, not to other funding agencies, because we'll get more FEC out of it. Do that, and then we have to wonder where that money is going. So this statement, as we know, will be going later in 2018, perhaps April or so on. What's called HEFCE, the Higher Education Funding Council for England, is going to split in two. There'll be an office for students, and there'll be Research England, where once HEFCE was, and these two things will be different. So until now, HEFCE, which generates money for both students and research, sends a cheque to the university. Each university gets a cheque, one cheque for everything. You spend it as you want in a reservoir model. That's why we can't track all of this stuff properly. But they will claim, potentially, that they're going to stop this because the Office for Students should be able to monitor or insist on the monitoring of income for the students. And you probably have heard they're arguing, this guy, Sir Michael Barber, is telling us that they're going to require institutions to explain pay and salaries which are higher than £150,000. What else is going on in universities that mops up the money? Well, we have something that significant numbers of academics have been concerned about. That's large numbers of supporting staff, and in some cases substantially outnumbering the academics in the institution. And there are plots here which show the numbers of these people, and then you can see on the left, for instance, down at the bottom, how, if you look carefully, the salary ranges of this groupings of people is increasing over time. And the problem here is the income that you might want academics to generate is not necessarily being forthcoming from this group of people. Of course, on that list, you've got the top ones in terms of minority of academics in institutions, and Durham has a, whatever it was, 61% surplus, according to that. Okay, that's all this story about the research and the income and where it's going, or where we can't work out that it's going. Here's a bit of an exercise to do with the RAE. If you're new to the universities, you may never have heard of it, and the RAE is kind of obsolete because it's now called the Research Excellence Framework, the REF. The REF is now running every 6 years, and it takes about 3 years in the run-up to this to prepare for it, and that's what I was referring to earlier. This is taken dreadfully seriously, and there are academics who spend vast amounts of time, and their IT systems are largely implemented in order to be able to track this. What are they tracking? Research performance. Might be grant income, it'll be publications, citations, and goodness knows what. Over a period dating back even to the 1980s, we've been running such exercises, and this just gives you a sense of the numbers of people who've been actively involved in this stuff. And there's data on how they're rated. But the problem with this is that, like any system that you introduce, perhaps with the best intent, it leads to things coming up that you weren't ready for. And whereas we can see positive benefits to RAE, REF in a certain, like, academic football premiership sense, there's been a lot of dynamism. People coming into new institutions being offered deals to bring themselves in, or their groups, because that means there'll be more income to the recipient institution because they've got someone who's a big hitter who lands more grants, contributes to their RAE weighting. Let's look now at what happens when we do the analysis of the data here. This means not just numbers, but the way the numbers pan out for the applicants to the RE. It's very intrusive in the sense that every academic who's supposedly research active must return a certain number of publications to this thing which are evaluated, and there are 4 of those per academic. Well, at this stage there's a lot of data available so we can look and investigate this. What I'm going to disclose here, with permission by a colleague of mine called Mochi Groenzu, who's at the London School of Economics, is what happens when we study the consequences of carrying out the RE. And I don't think anyone's done this before. But if you want to play the game with data to claim that we're doing well, then you have to pay attention to the consequences. And what this shows in a set of plots here, and I won't have time to go through them all in glorious detail, is by conducting this exercise, we're actually degrading the quality of the research we do. It's like a quantum mechanical system if you're well schooled in quantum mechanics. If you make an observation on something, you change what you're looking at. That's what happens here. On the right, actually, this particular graph shows the decline of the impact of the publications during the period of an REF process, because the number of internationally co-authored papers in high-impact journals is declining over that period. It starts to pick up afterwards. On the left-hand side, what we're seeing in detail is that of the order of 35% increase in the number of publications that people put in for an RAE or REF in the last year because they think it's a good idea to return their latest work. And down on the bottom, the degradation in the quality of those data. Essentially, on the left, if you're research was invariant under the exercise, which it would be if you didn't really stop, if you didn't make people game the system, those plots on the left would be flat, but they're degrading. They go down because the number of citations of the papers that people put in goes down with it. So there's all of this. I think in view of the time, I won't dwell on many of the other areas. I want to come now to the industrial collaboration side of things. To repeat what we said earlier, people think that the UK is a great powerhouse for doing research, but in fact the relationship of UK academia with industry in general is poor when you take the average behaviour. I know there are good individual examples of it, but it was only a month ago when Joe Johnson at a HEFCE conference was announcing that the revenue coming in and the growth of it to UK universities from industry was lower. It was only about 1%, and massively lower than any of its other competitor nations. And can you see where it is? In that graph on the left, I'll show you where it is. UK is right down there in terms of income per academic from industry. The leader on the left is Germany. Per academic, substantially the most. And that's just because the way they work with industry is much easier. This is the one that we got from Imperial College. They answered most of our questions. People in most academic institutions know if you try to do a collaboration with industry, you're going to fight your management, who will ask you to get 100% FEC or preferably more, and they'll want retention of all the intellectual property, and therefore they stymie many of these collaborations. But this is one of the leading places in the UK, and that's what their indirect costs are. And I suggest one of the reasons why they're most successful in their collaborations with industry is because they don't take such a narrow view. Because the concern I have here is by being hidebound and looking for money and trying to grab intellectual property, you're completely annihilating the other benefits that accrue to a collaboration, which are to the academic and to the institution, and indeed the links between academia and industry. It's significant factors, but they're less tangible. So I have examples that we could relate of the same sort of things going on. You try to set up a collaboration to fund something which might go on for 5 years. The partner just withdraws because after a year or so of trying to negotiate, they're getting nowhere, and the institution is trying to take all the IP ownership, taking far too long, and then we lose a collaboration that could have been extremely beneficial to the institution. That's the problem with industry connections in the UK. What about Europe? So, EU funding. If you're in the area which I am in, and Nick mentioned that I do lots of things in supercomputing, high-performance computing, where is the UK in this space? Right now, not particularly strong. If you measure things by the so-called top 500, our national supercomputer is dropping almost like a stone. It's around 79 now. We have collaborations with Germans. The Germans in Europe are the dominant force. They have 3 very powerful centres. We do collaborations with them. Here it's with the Leibniz Rechenzentrum in Germany, and we've been able to run calculations, scientific ones, which have led to a lot of so-called high-impact publications, which we couldn't do if we weren't using these resources. And, to my great pleasure, we have registered in the Gauss Center for Supercomputing, which is the combination of all the 3 centers in Germany, their 10-year anniversary publication on the most significant things that have been done in that period included this particular activity, where they gave us the entirety of 2 phases of the super machine, which is a combination of about 250,000 cores, just to us. And that's the benefit of working in a European collaboration. Then we have other things. I do computational biomedicine. This is an EU centre of excellence in that space. But what's different about an EU project is we couldn't get this work funded in the UK because it's funded by a different set of people, and they have different evaluation criteria, different review system that promotes the development of these techniques and technology, and to persuade medical scientists to pay attention to them. In the UK, we can't do this because we have more localized and fragmented peer review groups that don't understand the technology. So this is one of the reasons why we need diversity, we need different types of funding schemes, and the European ones offer a radical difference to what you can get only in the UK. This is a slide that tells you what's going on in terms of research funding, a pie chart which shows you where the European money is from 2013 to 14, I think it is there. And on the left-hand side, little wedges which show, for example, the amount of charity income to the UK, just for as a matter of interest, is far higher at 13% than the industry input, which is a mere 4%. And charitable income to UK universities, which doesn't come with full economic costs and is complemented by hefty to that account, is dominated by only 3 universities, Oxford, Cambridge and UCL. And then you can worry about how institutions depend on or expect to gain income from European projects, and you may or may not be aware of this. I list here for you the top 4 recipients of EU funding inside the EU as a whole, and they're all in the UK. So the top 4 in the UK are the top 4 in Europe. So you tell me that we're not going to be affected by being out of this. And the problem we have here is that it's already causing massive reputational damage to the UK by our not being able to guarantee our presence. And of course, we're no longer in the discussions that define what Framework Programme 9 is, which is the one after Horizon 2020. So if you have that level of active involvement and leadership in EU projects and you're saying we're going to just walk away from it, then you need to have your head tested. Conclusion. Hope that's okay, Nick. Having gone through this rapidly, you can see that the number of UK Research Council grants has fallen dramatically, actually, over the period, but there's demand management to make people feel that it's not as bad as it actually is. You've got this problem of collective punishment and individual on applicants, so people are penalised for failure and the idea of innovation starts to dwindle. The mantra that research in UK universities is loss-making, I don't think is true, although it keeps being said, it's convenient. The assertion that research income at 100% is the only way to break even is not the case. And we don't have a mechanism for investigating what's going on with the FEC in universities. The universities tell us they don't know if the UK fees are subsidising research because they don't actually separate the streams out clearly enough to do it. We have a problem with our engagement with industry, and the reasons for that, to my mind, are quite clear. One is we'd like to take as much money as we can out of the collaboration, and we'd like to control the IP. And that's not conducive to good, solid collaboration. And the last thing here is that Brexit is degrading our activities in science in many ways, including all these topics that I've alluded to, research impact and the reputational damage, which is hard to quantify. So that's the last slide. I just want to stop by thanking the people who were involved in working on this project with me. Not all of the people whose faces and names are listed there necessarily agree with all the things I've said, but they've been essential people active in collaboration and discussion with me. Some of them are in the room tonight, and others are from UCL or elsewhere. And HESA is one of the sources of the open data you can get. And with that, I'll stop and thank you very much for your attention.